Here's our Milwaukee dry cut saw and stand. We can run a couple different blades in here. The dry cut, as this machine does come with this blade here. It's 72 teeth. It's 14 inch. They're carbide tip blades, and they're cut on a cut for mild steel. These are not designed for aluminum, as they will clog. The aluminum's got a different cut angle to them and a anti-clog cut with the aluminum. So these are meant for mild steel. Over here we've got the diamond blade, and this one here has got diamonds that is electroplated to the edge here. These are becoming very popular. Nice thing about these is very durable, and the teeth do not break, and these last a long time. The problem with these blades here is if you're overworking the blade and getting it too hot, it will wear out right away, like within a few cuts. So you can only do so many cuts within a minute. It doesn't suggest that in the package or in the literature to the machine, but just known from use that you can only do maybe 3 cuts in a minute. Anything more than that, you will heat up the blade. These are just silver soldered on, carbide teeth, and it is run dry, so no fluid here with this one, no cutting fluid. When you get the blades in the package here, it does come with optimizing cutting performance. This one's here is color. So for this one here, we are positioning the material ahead of the center line of the blade, and the operation manual for this one does have pictures of these. So as we're looking here, I've got a pipe in here now. That's as far forward as this backrest will go, and it's got a simple push button here. We can bring it further back, and it's got an angle on it here as well. If you plan on cutting flat bar, in the book here it does say and state that it wants the thinnest part of the material facing the blade. So it's a little bit different than the bandsaw. The bandsaw always wants the thickest part facing the blade, because you don't want to break the teeth. The thing with this is it wants the thinnest part facing the blade to reduce the heat, because the thicker part, if it's going through something thick, it's going to increase the heat. So thinner, less heat. When it comes to angle iron, this one here it states it wants to be cut like this as a tent. Same with the bandsaw, and that'll work here for this. I've read in other manuals and other saws also, this is a thin part. They work well this way as well. It does go through thin, but then it gets thick, and that's the problem with this. So if I change the blades out to the diamond blade, I might even cut this like this. This is a pretty thick piece of angle, so there's probably not going to be much of an issue with cutting it like this. When you get into thinner angles, like this one here, the 1x1 1/8, the problems with these thinner angles are they do tend to flip up. They are a little thinner, they vibrate a little bit more, they do tend to flip. They are fairly thin, so putting them in the machine like this, it does stop the flipping or the rotation of the piece of material. So for the thinner stuff, I would recommend going this way. For the thicker stuff, I would recommend going this way. Also, when you're about to do a cut, try to go bigger than an inch. So if you have small cutoff pieces to do, the problem is if you get something small like 1/2 inch, the little cutoff could get up inside here on the guard and can break the guard. That's the problem with cutting off small little pieces. If you are cutting off a small little piece, do not cut all the way through and leave a little tab on the bottom, and then when you're done your cut, you can just break it off. Then it doesn't fly off. That's always a major problem when you're doing your cutoffs. So for this one here, there is a timing. Let's go ahead, we'll clamp this into the machine. I'm gonna make sure that I've got more than an inch here. We do have the the dry cut carbide blade in here. There is a how many suggested for seconds here. So we've got 1 inch schedule 40 pipe, 1 second. So we're twice the size of that. So 1 to 1.5 seconds. We're looking for about 3 seconds to get through this piece of material. Okay, again, wear your face shield. Make sure the guard is working and everything's functioning correctly. Okay, we're all plugged in, ready to go. And here we go. Keep the head down until the blade stops spinning, and then lift the blade. So the piece that we cut, it was small enough, it fell off, and it's outside of the machine. So that was done there safely. You can see as I started cutting, there was sparks, and I increased my travel speed until the sparks went away. So start out slow, and then pick up your speed through the cut. Okay, and then that's basically this saw here. Okay. What I'm going to do now is I'm going to change the blade out, and I'm going to put this blade in here just to show and demonstrate this blade. So to do that, the locking lever is broken on this saw to lock out to undo the blade. Make sure you undo the power here. So turn the power off anytime you're working on a machine. So I'm going to have to lift to expose the securing bolt, and on this one here I'm just going to have to press the blade into another piece of material. I'm going to back this off. Looking for a spinning direction on this one. Don't see any. I think it's both ways. You can get these blades for a 5-inch grinder as well for a zip cut. They work really good. They also make them in a 7-inch for a skill saw as well. You get 1,000 cuts out of 1x1 square tubing, and that would be steel. That's a lot of cuts, and then it'll even do more than that. It is a little slower. It does create a little bit of a burr at the end, but it's a nice safe blade, and it never wears out. The cost of the blades, this is about a $150 blade here, and I've seen these blades wear out in a day from misuse, just running them too hard. These blades over here are coming down in price. These are under $100. So this blade will outlast this blade by quite a lot, so up to 50 times. So for this one here, I'm just going to make sure I've got this a little more than 1 inch there, and this one you are going to notice it is quite a bit slower. And comparatively to a cutoff disc, this one will have less sparks. Obviously not as less sparks as the carbide tip blade. So we'll plug this in. And we'll make a cut. Okay, so obviously it's slower, and obviously it's not as nice of a cut. It leaves quite a burr, There's obviously a lot more heat, a lot more friction in here. There is sparks, but there's less sparks than a traditional cut-off wheel, one that wears out. So we've been using this one here. It is a little bit slower. It's not as great as a cut, but we don't have to worry about replacing this blade here. The other problem with this here too is obviously the carbide teeth can break and come off, and as soon as you got one or two missing, this thing chatters a lot and is a major problem. So it works good. It's nice and quiet. There's little to no sparks. It's very fast. If you're the only one using it and you're not overusing it, it's a great blade and it works good. If you're looking for something that's more durable and will not wear out, then this would be a nice diamond blade would be something to go to. Okay, that's about it for this saw. There is an instructional manual with some safety. For the most part here we're just trying to get our material in, and we're just trying to make a cut. And again, making sure not to cut off small pieces because those can get stuck into the guard. There's their Milwaukee dry cut saw.